Good day everyone, especially to our instructor, Ma'am Dean, Engineer Maria Lizel Gallardo, PhD. Good day to you, ma'am. We are the Group 3 members and I am Rosalyn Cagas, together with my group mates, Princess Lian Misefra, Giselle May Albet, and Jean Kyle Cario. And for today's discussion, we are going to tackle about the soil pollution. And here we have the subtopics or the subtitles, which are the soil of the Philippines, Bureau of Soils and Water Management, 5 factors of soil formation. Also, we have the soil characteristics, soil layers, soil texture, soil color, and also we have the Philippine soil region order, Philippine major soil type, the soil pollution, pollutants that contaminate soil, processes that causes soil pollution, negative consequences of soil pollution. Also, we have the controlling soil pollution, and lastly, the loss of soil pollution. And by the end of this discussion, we are hoping that everyone will understand of what we've tackled. And to formally start, I will give the floor to Giselle May Albet to begin with the discussion.
Soil. Soil is a natural resources composed of minerals, organic matter, water, air, and living organisms. It serves as a medium for plant growth and plays a crucial role in various environmental processes. Here in Philippines, as an archipelago, we had more than 7,100 islands. The Philippines is blessed with a natural diversity of soil resources. The task of configuring these soil resources, classifying to the soils on the basis of its natural history. Assessing its agricultural potential in terms of sustainability, the economically important crops and productivity for sustainable production falls on the Bureau of Soils and Water Management. Bureau of Soils and Water Management. The Philippines Bureau of Soils and Water Management, or the BSWM, is an agency of the Philippines government under the Department of Agriculture, responsible for advising and rendering assistance on matters relative to the utilization of soils and water as vital agricultural resources. So, the Bureau of Soils and Water Management is sila ang mo-assess sa atong mga farmers para magdumala or pamamahala sa mga yamang lupa to maintain ang maong soil productivity and farm profitability and consequently boost the natural economy, enhance global competitiveness of local produce, and improve the quality of our soil and water. The soil characteristics. There are 5 key factors that influence the soil formation. The first is parent material, the second is climate, the third is topography, the fourth is organisms, and the fifth is time. The first one is the parent material. This refers to the original rock or sediment from which the soil develops. So, parent materials is naka-influence sa soil formation in a way of through their mineralogical composition, their texture, and their stratification. And also when the parent materials is exposed sa maong atmosphere or the organic matter or minerals are deposited on the earth surfaces, ana mag-start ang maong soil formation. The second one is climate. Climate is a temperature and precipitation play crucial roles in weathering processes, organic matter decomposition, and soil moisture levels. Different climates lead to varying soil types. So, ang soil is magdepende ano nga area kung unsa ang iyang climate. So, the climate is influenced into soil formation in a way of due to high temperature and rainfall increase, the degree of weathering, and therefore the extent of soil development. So, high temperature and rainfall is naka-influence it's because of the process of breaking down rocks and releasing nutrients into the soil. And also it's a process which help the plants access the nutrients. So, however, is naapoy times nga if too much ra ang rain, it make the soil become acidic. and remove nutrients when sobraan na sad po siya kagamay is it can lead siya sa soil nga lack of organic material. The third is topography, which the landscape shapes and slope influence drainage, erosion, and sunlight exposure. For example, soils and steep slopes may be thinner and more prone to erosion, which valley soils may accumulate nutrients. So the topography can influence the soil formation in a way of it contributes the fast degradation of rocks, which contributes to the composition and formation of soil. Fourth is organisms. Organisms are living organisms including plants, animals, and microorganisms. Contribute to soil formation by breaking down organic matter, aerating the soil, and influencing nutrient cycling. So the organisms can influence the soil formation in a way of adding organic matter in which plants add their leaves and roots to the soil, while animals contribute their waste and bodies and decomposing organic matter, which are microorganisms like bacteria and fungi break down plant litter and animals' waste into organic matter like humus, peat, and charcoal. Then the aerating the soil is animals like earthworms tunnel through the soil, which help aerate it and allows water to penetrate more deeply. Then the last is influencing nutrient cycling, in which microorganisms control the cycles of carbon, nitrogen, and sulfur, which are essential for plants. The fifth or the last is time. Time is a soil formation is a gradual process that takes place over a long period. Older soils typically have more developed horizons and greater complexity compared to younger soils. So the time can influence soil formation in a way of soil's age or ang yuta magkadugay in which mineral change or mausog ang mineral from one form to another. Then the chemical compounds and clays are carried downwards through the soil profile and organic matter. There are 6 salt horizontal layers. The first one is humus, the second is topsoil, the third is elevation layer, the fourth is subsoil, the fifth is regolith, the sixth or the last layer is the bedrock. The first one is the humus or the top or organic layer of a soil. So it is improving the soil structure and a very large surface area that could hold nutrient elements. The second one is the topsoil or the seeds germinate and plants roots grow in this dark colored area. Or the topsoil provides seedbed for the germination of seeds and the establishment of a rooting system for the crop. The third is the elevation layer, or this elevation or leaching layer is light in color, or it is a removal of minerals and organic matter leading to a lighter color and fertility. So in this layer, which water can move through, may makakos remove sa maong nutrients and minerals from the soil. The fourth is the subsoil or the subsoil. It contains clay and minerals deposits like iron, aluminum, and oxides that it receives from layer above and when mineralized water drips from the soil above. So, ang subsoil siya ang ma-provide of critical layer sa overall na health sa plants o sa soil. Fifth is the regolith layer or it consists of slightly broken up bedrock. So, ang regolith is an excellent thermal insulator. So, ang regolith layer, siya ang ma-protect sa target bedrock from impact of small to moderate size, redistributing energy. The sixth or the last layer of the soil is the bedrock. It is the unweathered rock or bedrock layer. It is often served as the parent material, the source of the rock and mineral fragments for regolith and soil. It also a source of nitrogen on Earth's nitrogen cycle. So, ang role sa bedrock is Siyamoy mo determine sa type sa soil for vegetation, groundwater, and construction activity that can be carried out. Next is the soil texture. There are three types of soil texture: the sand, the sandy loam, and the clay. Sand. The sand texture is a light soil texture or the sand particles and feels gritty to touch. So yung characteristics is often acidic, low in nutrients and warm up quickly, and then dali po siya ma-drain if mawanan, then mabasa. Then ang sand is kadalasan siya may use in fast draining of cultivation then planting. The second is the sandy loam, and the texture is high content of sand. Then its characteristic is you can see and feel the individual sand grains when it dry. It forms a cast that falls apart easily, and when moist, it forms cast that can be handled. So, the sandy loam is kadalasan po siya magamit for gardening. So, the last one is the clay. So, ang texture sa clay is you can feel silky, smooth, and greasy. Then, it also sticky kung mabasa. Then, ang yung characteristic is heavy, then can hold water, then it is rich in nutrients. Then, ang clay is kasagaran siya magamit for some industrial processes like cement production, paper making, then also in chemical filtering. So, the next part is the soil color. So, there are different types of soil color. So, there are dark color, red, yellow, and whitish gray. So, the red color is the high percentage of organic matter. Then, the red is good for drainage. Then, the yellow is well drained and low in iron. Then, the whitish gray is low of minerals.
In this slide, there are 12 soil orders that are recognized. The difference among orders reflect the dominant soil forming processes and the degree of soil formation. Each order is identified by a word ending in "sol". Empty soil is known as the less developed soil, while oxysols is the highly developed. In between of antisol and oxysols are histosol, andisol, gelesol, incepsol, aridisol, vertisol, alpisol, mollisols, ultisols, and spodisols. So these are the following development of soil. Antisol is recent. Histosol are organic, deep organic matter, wet conditions. Andisol is volcanic, mild weathering. Gelesol are permafrost and very cold. And septisol, not much, pure zone development. Ardisol is dry, desert condition. Vertisol is swelling clay, high base, dry season. Alphisol is mildly acid, glaze, moist. Mollisols are soft, dark, semi to moist grassland. Ultisols strongly acid, glaze, wet, warm, acid silicate, and oxides. Spodisols are spodic, cool, wet, sand, acid, coniferous forest. And lastly, oxysols or oxides, wet, tropical, ion activity, clays, extreme weathering. Slide is the Philippine Soil Religions Order. And the next slide is their explanations. First is abyssal soils with subsurface horizons of clay accumulation and medium to high base supply, either usually moist or moist for 90 consecutive days during a period when temperature is suitable for plant growth. Second is entesols, soils without pedogenic horizons, either usually wet, usually moist, or usually dry. Insectisols are soils with pedogenic horizons or alteration or concentration but without accumulation of translocated materials other than carbonated or silicon, usually moist or moist for 90 consecutive days during a period when temperature is suitable for plant growth. Oxysols are soils with pedogenic horizons that are mixtures especially of kaolinite, hydrated oxide, and quartz, and are low in weatherable minerals. Ultisols are soils with subsurface horizons of clay accumulation and low base supply, either usually moist or moist for 90 consecutive days during a period when temperature is suitable for plant growth. Vertisols, soils with high content of swelling, clays, deep, wide cracks develop during dry period. Soils in areas with mountains, soils with various moisture and temperature requires many step slopes. Relief and total elevation vary greatly from place to place. Soil vary greatly within short distances and with changes in altitude. Vertical zonation common. In this slide, we tackle about Philippines' major soil type. Based on interpretation of soil map of the Philippines, Mariano and Valmidiano, 1972, as cited by Barayos, 1994, the country's soils may be grouped into 6 soil orders, namely ultisols, alphisols, insectisols, vertisols, entesols, and oxysols, except for the aridisols and spodisols, the other soil orders. Histosols and melosols are also observed, but to a limited extent. In the next slide are the land area covered, percentage of soil types. First is ultisols, 41.5%, insectisols, 13.7%, alphisols, 9.9%, vertisols, 3.6%, entesols, 2.5%, oxysols, 0.3%, and unsurveyed mountains is 28.6%. Our next content is soil pollution.
Soil pollution refers to the contamination of soil with anomalous concentrations of toxic substances. Soil pollution. It is important to understand that all soils contain compounds that are harmful or toxic to human beings and other living organisms. However, the concentration of such substances in unpolluted soil is low enough that they do not pose any threat to the surrounding ecosystem. When the concentration of one or more toxic substances is high enough to cause damage to living organisms, the soil is said to be contaminated. Soil contamination. Soil contamination is a form of land degradation brought by the spillage, migration, or burying of hazardous contaminants to the soil ecosystem from untreated industrial influence, manufacturing waste, local waste, agrochemicals, and other man-made substances or activities. Soil contaminants not only affect the soil but has an adverse effect on animal, plant, and human health as well. Exposure to contaminated soil may come from breathing, swallowing, touching, or ingesting food grown in contaminated lands. Soil contamination usually occurs in urban areas and former industrial and mine sites.
Soil contaminants can come from various sources, including industrial activities, agricultural practices, and improper waste disposal. And there are lots of types of soil contaminants, like petroleum hydrocarbons, agrochemicals, polycyclic aromatic hydrocarbons or PAHS, solvents, lead, asbestos, heavy metals. So, what is petroleum hydrocarbons? Petroleum hydrocarbons originates from crude oil and natural gas leaks, often near oil wells and urban pipelines. They disrupt soil properties, increase organic matter, and reduce soil structure, making it more prone to erosion. Petroleum hydrocarbons are oil spills, leaking storage tanks, and petroleum-based products can introduce contaminants like benzene, toluene, and polycyclic aromatic hydrocarbons or PAHs into the soil. Agrochemicals. So, agrochemicals includes pesticides, herbicides, and fertilizers used in agriculture. Improper storage can lead to spills and runoff, harming beneficial soil organisms and reducing fertility. Integrated pest management is a better alternative to over-reliance on these chemicals. Polycyclic aromatic hydrocarbons, or PHS, carcinogenic chemicals produced from incomplete combustion of organic materials and fossil fuels. PHS are resistant to degradation, posing serious health risks and altering soil properties like grain size and porosity. And proper disposal of medications and personal care products as well as wastewater runoff can introduce chemical residues into soil. Solvents. Solvents used in industrial processes. Common examples include tricolor toluene and other chlorinated solvents. Improper handling leads to soil and groundwater contamination. Reducing fertility cleanup methods include aeration and bioremediation. Lead. So, what is lead? Lead naturally present but elevated due to industrial activities and leaded products, persistent and does not degrade, posing serious health risks, especially to children, linked to mental impairment and development issues, common in areas with heavy traffic and previously used in gasoline paint. Asbestos. Asbestos is common in construction materials like roofing tiles. Pollution often results from poor demolition and disposal practices. High exposure can lead to serious lung diseases, including cancer. And lastly, heavy metals. So what is heavy metals? Heavy metals are found in industrial areas, mining sites, and from fertilizers. Metals do not break down and accumulate in soil, posing health risks through ingestion or contact. They can also reduce soil fertility and agricultural productivity. Remediation methods include soil washing, phytomediation, and immobilization to enhance safety and land productivity. These contaminants can have significant impacts on soil health and the wider environment. Now, understanding these contaminants and their sources can help in addressing soil pollution and developing strategies for remediation and sustainable soil management. So, now let's move on to the next topic. What are the negative consequences of soil pollution? Soil pollution harbors a broad spectrum of negative consequences that affect plants, animals, humans, and the ecosystem as whole, since children are more susceptible to diseases like polluted soil poses a greater threat to them. Some important effects of soil pollution are detailed in this subsection. So, what are the effects of the negative consequences of soil pollution on humans? Soil contaminants can exist in all three phases, like solid, liquid, and gaseous. Therefore, these contaminants can find their way into the human body via, several channels, such as direct contact with the skin or through the inhalation of contaminated soil dust. It can be noted that many soil pollutants, such as petroleum hydrocarbons and industrial solvents, have been linked to congenital disorders in humans. Thus, soil pollution can have several negative effects on human health. While the effects on plants and animals, since pollution is often accompanied by a decrease in the availability of nutrients, plant life ceases to thrive in such soils. Soils contaminated with uh, inorganic aluminum can prove toxic to plants. Plants that are grown in polluted soil may accumulate high concentrations of soil pollutants through a process known as bioaccumulation. With these plants are consumed by herbivores, all the accumulated pollutants are passed up the food chain. This can result in the loss extinction of many. And the effects of these negative consequences of soil pollution on our ecosystem, since the volatile contaminants in the soil can be carried away into the atmosphere by winds or can seep into underground water reservoirs. Soil pollution can be a direct contributor to air and water pollution. Acidic soils are inhospitable to several microorganisms that improve soil texture and help in the decomposition of organic matter. Thus, the negative effects of soil pollution also impact soil quality and texture.
Controlling soil pollution. How can soil pollution be controlled? Controlling soil pollution involves several strategies to prevent contaminants from entering the soil and to remediate existing pollution. So, here are some effective ways. First is the reduced chemical use. Limiting the use of pesticides, herbicides, and synthetic fertilizers in agriculture helps reduce chemical buildup in soil. Organic farming practices like using natural pest control and compost can also be beneficial. So, ani nga effective ways, the more ta nga mas less mo gamit sa mga pesticides or even sa mga synthetic fertilizers in farming or in agriculture, the more sad nga mas mo reduce or mas mo less ang pagkalat sa mga chemicals padong sa soil. And instead, using the organic farming, like using natural pest control or and compost, mas maka-beneficial ta and also mas healthy siya. And then the second one is the proper waste disposal, ensuring proper disposal and recycling of household, industrial, and medical waste prevents toxic substances from leaching into the soil. Hazardous waste should be handled and treated in specialized facilities. So, kaning number two or the second effective waste is dapat ma-ensure nato ang pag-dispose properly sa mga toxic substances, like example, if you are a student and then naka sa laboratory class nimo, then you have the experiment, and after doing the experiment, ang mga nagamit ninyo nga mga toxic substances na gyud na siya proper nga way of disposal para sa safety sa tanan, like para dili bitaw siya mas mukalat and then basin ay mas maapektuhan uban. And then another example also is kintahay naa sa hospital, kana magikapanggamit nga mga toxic substances sa hospital, na sila ay proper way of disposal para dili raingon o bisig asa nila ibutang bitaw after using. So ingana siya mo the reason why effective way siya kay para sa safety sa tanan. And then third one is the implementing strict regulations. Governments and environmental agencies can regulate industrial emissions and waste management to minimize soil contamination. Regular inspections and penalties for violators can help enforce these regulations. So, kita man tanan no kabao nga the more or ingani the more nga na ay rules and regulations sa isa ka community, the more nga mas responsibly ang mga tao sa ilang mga niliwkan. So here nahimo siyang effective ways tungod kay para bitaw ang mga waste dili siya para ang mga waste ma-minimize sa soil contamination, and also regular inspection sa mga penalties sa mga violators, the mas ma-realize nila nga dapat gyud every actions nila dapat ilang hunahon og insay possibility or posibilidad nga mahimong consequences. The fourth effective ways is the phytoremediation. This is the use of plants that absorb contaminants from the soil. Some plants can accumulate heavy metals and other pollutants which can then be safely disposed of. So kani siya gigamit ra ni siya para sa mga plants. And then the fifth one is the bioremediation. Using microorganisms to break down or neutralize pollutants in the soil can be effective for organic contaminants. Bacteria, fungi, and other microbes can convert harmful substances into less toxic form. Also, we have the preventing deforestation. Forests act as a natural buffers for pollutants. Protecting forested areas can reduce soil erosion and maintain soil integrity, preventing contaminants from spreading. And then also we have the recycling and composting. Encouraging recycling and composting organic waste produces the amount of garbage sent to landfills, which are the common sources of soil pollution. Also, composting organic waste also returns nutrients to the soil. So, kani dapat niya i-encourage nato ang tanan nga mag-recycle and composting of sa mga organic waste para mas ma-less ang amount sa mga garbage. And then also I knowing nga ang garbage is a common source sa soil pollution, and also by this also mas mo return siya og nutrients sa soil. And then also we have the reducing industrial pollution. Industrial should adopt cleaner production techniques and use eco-friendly materials. Treating industrial waste before disposal can reduce soil contamination. And lastly, we have the public awareness. Educating communities about the sources and dangers of soil pollution as well as responsible waste disposal and chemical usage can help mitigate pollution at the local level. So, ma-control na to ang soil pollution through public awareness like kanang like ipahibaon ang tanan sa inyong nga naa sa inyong community about sa mga sources and danger sa soil pollution, and then para sa mahimo silang responsibly sa pag-dispose, proper disposal and everything kay matod pa nila, di ba, like ana man gyud mag sugod sa community ang pagka-responsibly, or even sa family until sa community, until to the society, until to the higher level. So by this, combining these methods can help preserve soil health, protect ecosystem, and ensure food security by preventing toxic substances from contaminating agricultural lands. Our last topic for this discussion is all about the loss of soil pollution. So in the Philippines, several laws and regulations address soil pollution and environmental protection. Here are some key pieces of legislation. First is the Soil Pollution Act number 370. This is an act to prevent and limit pollution of the soil and to combat negative effects of polluted soil on groundwater, public health, and the environment in general. Also, this act addressed soil contamination by establishing guidelines for identifying polluted sites, managing soil contaminations, and implementing cleanup measures. Also, this act consists of 87 sections divided into 11 chapters. So, this task, or most tasks of the public administrations, are assigned to authorities at the municipal level. These tasks include mapping of pollution, enforcement, and other orders against polluters. So the second law is the Act number 1151 of 2003 to amend the Water Supply Act, the Environment Protection Act, the Pollution Act, and the Town and Country Planning Act, which means that this act amends various acts regarding the protection of the environment on the occasion and the introduction of the Act on Environmental Protection aims at related matters and so as to respect planning in the field of water and international nature conservation areas. The third law is providing for the revision of Republic Act number 3931, commonly known as the Pollution Control Law, and for other purposes. This act aimed to protect the environment by regulating waste disposal and emission from industries, controlling pollution in water bodies and at the atmosphere, and establishing penalties for polluters. This act was an important foundation for environmental regulation in the Philippines. And now, whereas there is a need to modify the organizational structure of the National Pollution Control Commission to make it more effective and efficient in the discharge of its function and responsive to the demands of the times occasioned by the accelerative phase of the country's industrialization program. The fourth law is the Republic Act number 9003, or commonly known as Ecological Solid Waste Management Act of 2000. This law aims to manage solid waste effectively and reduce its impact on the environment, including soil pollution from improper waste disposal. The fifth one is the Republic Act number 9275, or the Philippine Clean Water Act of 2004. While primarily focused on water quality, This law addresses the discharge of pollutants that can affect soil and groundwater, emphasizing the need of proper wastewater management. The sixth law is the Republic Act number 8749, or the Philippine Clean Air Act of 1999. This act regulates air quality but also includes provisions that can indirectly influence soil pollution, particularly regarding industrial emissions and their impacts on land. Seventh law is the Republic Act number 6969, or commonly known as the Toxic Substances and Hazardous and Nuclear Waste Control Act of 1990. This law regulates the importation, manufacture, processing, distribution, use, and disposal of toxic substances which can contribute to soil contamination. Also, we have the Republic Act number 7586, or the National Integrated Protection Area System Act, that which means that this act establishes protection areas in the country, helping to preserve ecosystem and mitigate pollution, including soil degradation. And also we have the Presidential Decree number 984, or the Philippine Environment Code. This comprehensive environmental law includes provisions in pollution control, waste management, and land use aimed at preventing soil degradation. We also have the Local Government Code of 1991, or the Republic Act number 7160, which means that this code empowers local government units, or the LGUs, to create their own environmental ordinances, which can include specific regulations related to soil pollution and waste management. And lastly, we have the Environmental Impact Assessment System, or the EIA system, which means also that under various laws, projects requiring government approval must undergo an EIA assessment, or AIA system, which assesses potential impacts on soil and other environmental factors. These laws are enforced by various government agencies, including the Department of Environment and Natural Resources, or the DENR, and compliance with these regulations is crucial for managing soil pollution and protecting public health and the environment. That's all for this discussion, everyone. Once again, we are the Group 3 members. Thank you for listening and God bless.